In this session, we're simply going to look at the 2024 quiz 3 for MAT1120. This is quiz 3, and we're going to start with question 1. So question 1 was on logs, so I'll just highlight or rather give you the quiz paper here, but then I won't be referring back to it on solving. So these were the questions. So there were only 3 questions. The first question on logs, and the second question and the third question were on trigonometry. So we'll start with the first question, which is on logarithmic functions. Question 1. So question 1a, they want us to get log 81 to base 1 over 3. What's the value of this? So we're simply going to equate this to x, and we say 1 over 3 to the power x is equal to 81. We're going to convert this from logarithmic expression to exponential. So it's going to be 1 over 3 to the power x is equal to 81. Then we can break down this by writing 3 to the power negative 1 to the power x. This is equal to 81. So this is the same as 3 negative of x is equal to 81. We're going to check whether 81 can be expressed with base 3. So 3 into this is going to be a 27. 3 there, that's simply a 9. 3 there, that's just a 3. 3 there, that's just a 1. So 3 can actually multiply itself 4 times. So 3 to the power 4 is simply 81. This is equal to 4. We're equating the powers because the bases are the same, right? Meaning x is simply negative 4. So this brings us to our answer to say log of 81 to base 1 over 3 is simply equal to a negative 4. So that's what you have. That's question A1. Then number 2, they're asking us to find the value of log of 1 over 64 base 2. So again, we equate this to x. So if you want, you can please pause the video and attempt it before you see how we're going to solve it. Okay, so we're going to have 2 to the power x is equal to 1 over 64. So 2 to the power x is equal to 1 over 64 from logarithmic form to exponential form. Then when you try to express 64 with 2 as its base, this is just going to be a 32. That's a 16, that's 8, that's a 4, that's a 2, that's a 2, that's a 1. This is 6, right? So this is equal to 1 over 2 to the power 6. This can be written as 2 to the power negative 6. From here, we just equate x is equal to negative 6. This is what you get as your answer. So meaning log of 1 over 64 to base 2 is simply the same as negative 6. So that answers your question number 1a. So after number 1a, we have the next one. The next one is simply on equations. So question 1b. Question 1b, they're saying we have 2, we have a 4x, then we are having minus a 17. This is 2 to the power x, and this is plus 8 is equal to 0. We check and look for the weird part, which is in simpler base. So by weird, I mean anything that has a value or rather a letter as its power. So here we're having 2 to the power x, and here we have 4 to the power x, right? So the one that's small between the two is simply 2 to the power x. So we are going to reduce the one which is big to be like the one which is small, and this is just going to mean that this will be 2 to the power 2. There's an x there because 4 is the same as 2 to the power 2, right? Then minus a 17, we still have a 2 to the power x plus 8 is equal to 0. From here, we can now swap the x and the 2. This guy is here. This, we have 17, 2x plus 8 is equal to 0. From here, we can let k be equal to 2 to the power x, so that we are now going to have k squared minus 17k, then plus 8 is equal to a 0. We want it to be a quadratic. Then from here, we're simply going to solve this using the normal way. Product is simply equal to 16. The sum is negative 17, meaning the factors could be negative 16 and negative 1. So this will be 2k squared minus 16k minus k. Then plus 8 is equal to 0. And this is going to be 2k. Then we have k minus 8. Minus 1, this is k minus 8, this is equal to 0, 2k minus 1, then we have k minus 8, this is equal to 0. We solve each one of these, so you have your 2k minus 1 is equal to 0, meaning from here, 2k is equal to 1, divide both sides by this, k is equal to half, we keep this. Then we have this other part, which is k minus 8 is equal to 0. This will now be k is equal to 8. That's what you have. Then from here, remember we're not looking for k. The expression didn't have k. We had x. And remember that we said k is equal to the power x. So wherever there is k here, we'll bring back the 2 to the power x. So we're going to have 2 to the power x is equal to 1 over 2. And this side, we're having 2 to the power x is the same as 8. We try to see if we can change this to base 2. So this is the same as 2 to the power negative 1. 2x, this is the same as 2 to the power 3, right? So meaning x is equal to negative 1 and x is equal to a 3. So these are the two answers for the equation, the logarithmic equation that we have. So that answers your part A of question, part B, B1. Yeah, so question 1b. Then the next one we are having is log 3. There is an x plus a 4 minus the log, there's a 9, and this is 27 minus 2x, this is equal to a 0. We change the 9 to base 3 because the bases are not the same. We need the bases to be uniform, and the rule for change of base, so change of base, is that if you are changing something, let's say this, you want to change this to base x, this is just going to be log the new base, then put this guy here, that's what you have, over log the new base, put this here, so it's going to be like that. So this is what you get if you are changing the base. We're saying this is simply this whole thing here, just that it's now in base x. So we have 3 and a 9, so we're going to change the base to be the smaller base. So we change the bigger one to mimic or to be in terms of the smaller base. So this is going to be log 3, then x plus 4 minus log, the new base is 3, 27 minus 2x, then down, we just say this is log 3, then there's a 9 is equal to 0. Now previously on question 1a, we did solve things that look like this. So what is log 9 of 3? How many times should 3 multiply itself to give us a 9? That's simply what we are asking when we say log 9 to base 3. Yeah, so the answer is 2, right? If you are to solve it, it's simply going to give you a 2. So the bottom part will be having a 2 is equal to 0. Then from here, I'm simply going to multiply everything by 2 to get rid of this fraction. This is going to become log this x plus 4 minus log, this is 3, 27 minus 2x is equal to 0. And from here, we don't want to see anything in front of the log, so I'll take back the 2 there using this rule. Log n, remember this is the same as n, log a, right? This guy, this is the rule that we're applying. The 2 will come back here on top. So this is going to be log 3 x plus 4 to the power 2 minus log. The reason why we're doing this, why we're taking back the 2 as the power, the same thing if we had a number here, would have taken it back here as the power. Because we don't want to see anything in front of the log expression, because we want to apply that principle that says, there's a rule that says, provided things are having the same base, You're saying the base is the same, right? There's nothing here, there's nothing here, and there's a minus in between. This is the same as log A minus B, right? That's a rule that I want to apply. So if we were to apply this rule here, it's now going to be log 3. You have x plus 4 to the power 2 over, this is now 27 minus 2x is equal to 0. Then from here, we change this from being in logarithmic form, we change it to exponential form. So we're saying 3 to the power 0 should give us this thing there, right? 3 to the power 0 is equal to x plus 4 squared over 27 minus 2x. 3 to the power 0 is simply 1. This is on top here. If you want, you can just expand it in advance. This is x squared plus 8x plus 16. Down you get a 27 minus 2x. There's a 1 there. Then here we can cross multiply. This is x squared plus 8x then plus 16 is equal to 27 minus your 2x. Then here you are simply getting a quadratic. This is going to be plus a 10x. Then you're saying plus 16 minus 27 is equal to 0. So 27 minus 16, this is 1, 1. So this is technically giving us negative 11, right? 16 minus 27, this is negative 11. The product here is negative 1. The sum is just a 10. The factors here are going to be, what numbers can we use? We multiply. So this is going to be 11 and a negative 1. This is x squared minus x, then plus 11x, then minus 11 is equal to 0. X and x minus 1 plus 11 and x minus 1 is equal to 0. So now this is x plus 11 and we have x minus 1. We solve each one of them. This will give us negative 11 and then this one will just give us a 1. So these are simply supposed to be the two answers that can make the whole equation that we had to be true. So this is how we tackle such particular questions. Hope this is okay. The next question. Question 1C is simply asking us to sketch, stating the domain and the range. So we're given something like y is equal to ln. We're having 1 over the 2 minus x. Yeah, so this is simply going to be the same as y is equal to ln. This is the same as 2 minus x to the power negative 1. Y is equal to negative 1. No need of even writing the 1. We're just going to say ln 2 minus x. That's what you have. Yeah, so now if this is what we have been given, we can get the expression here to be the vertical asymptote. So the vertical asymptote is going to be 2 minus x is equal to 0. So we're having 2 minus x, this part here. Negative x is equal to negative 2, meaning x is equal to 2. So we're having an asymptote there. Then we have, for the domain, for you to get the domain, we're just saying 2 minus x should be greater than 0. So x is greater than negative 2, meaning x is less than a 2. So the domain is simply from negative infinity up to 2 open. That's what you have. Then we can come here. We try to make a sketch. So we're saying we should never touch this guy. That's our 2. Then if you check between the x and the y intercept, so this is supposed to be when x is 0, when x is equal to 0, this is just going to be y is equal to negative ln 2. So negative ln 2 is somewhere there. Then if y is 0, so if 0 this side, negative ln, this is 2 minus x. This is the same as 0 is equal to ln 2 minus x. The negatives can cancel. There is e here. E to the power 0 is equal to this. This is a natural log expression. Yeah, so this is just going to be e to the power 0. Whenever there is ln, remember we said the base is always going to be e. So this is 2 minus x. This is a 1. This is 2 minus x. 1 minus 2, negative this, x. This is negative 1, negative x, so meaning x is equal to 1. So we are passing here at 1. Yeah, so the graph is simply going to be something that looks like this. It just goes like that. So this is the domain here. This is the domain. The range is all real numbers. All real numbers. So y, all real numbers from negative infinity to positive infinity. That's what you have. So this answers your question 1C. Then question 2. Question 2, it simply says find the exact value of the following. So question 2 is on trigonometry. So question 2a, they want us to get the exact value of tan 75. This is the same as tan. We break it down because 75 is already in the first quadrant, right? So we're going to just look for special angles between 30, 45, and 60 that give us a 75. So we're going to use the double angle for tan, which says tan of A plus B is the same as the tan of A, then plus the tan of B over, this is 1 minus, this is just tan of A, then you have tan of B there. That's a rule that we're going to apply. So now we're saying tan of 75 is just the same as tan 45 plus tan for 30, then over, this is 1 minus tan 45, then tan 30. So now according to your special angles, you know what tan 45 is. It's a 1. Tan 30 is just 1 over root 3. Then we're dividing this by 1 minus 1 over root 3. Because this is a 1, right? Then this is 1 over root 3, right? So multiplying, that's where this is coming from. So now here, we try to make these as fractions. So the first one is simply going to be root 3, then plus a 1 over the root 3. This guy is being divided by root 3 minus 1 over root 3. This is equal to root 3 plus 1, then over root 3, multiplying root 3, then root 3 minus 1. This is going to be, we cancel this, root 3, then plus 1 over root 3 minus 1. We cannot leave it here because we are able to rationalize, so we're going to multiply by the conjugate of the denominator. This is simply going to be given like this, and this becomes a 3. This is a plus root 3. Yeah, so we're having root 3 again, then plus 1, then down you just have a 3 minus 1. This becomes a 4 plus 2 root 3 over a 2. This is the same as 2 plus root 3, because everything here is divisible by 2, right? 2 there, 2 there, 2 there, so you get this. So this is tan 75. That's how you're supposed to do it. Then the next one is simply question 2a2. So this is just sec squared of 15. This is 12 like this. Now when you convert this, 1 pi is equal to 180 degrees. So pi over 12 is equal to what in degrees? So this gives you a 15, if I'm not mistaken, 15 degrees. Now you know what sec is. Sec alone, if I give it a sec 15, this is the same as 1 over cos 15, right? Now this thing is squared, meaning even this part also has to be squared by the time you are done. So once you get your cos 15, which is the same as what? When you say cos 15 is the same as cos 45 minus 30, using your double angle for cos, this will be cos 45, cos 30, then this is going to be plus, you have sine 45, then you have sine 30, this will just be 1 over root 2, cos 30, this is adjacent of hypotenuse, this is going to be root 3, this is 1 over root 2, this is simply half, this will turn out to be root 3 over 2 root 3, then plus 1 over 2 root 3. When you add this, this is just root 3 plus 1 over 2 root 3. Now we're saying square this, right? This is a root 2, sorry. So we're saying square this thing, right? So we are putting it down first. So this is the same as sec squared of 15 is the same as 1 over this guy here, root 3 plus 1 over 2 root 2. This guy here is squared, right? We can flip what's inside to be 2 root 2. The reciprocal, that's root 3 plus 1 before we square it. So the top part will just be this. The down part, when you square it, when you square root 3 plus 1, this guy here squared, this will be 3 plus 2 root 3, then plus 1. This is just going to be 4 plus 2 root 3. So it will be 4 plus 2 root 3, 8, 4 plus 2 root 3. We can actually cancel this part here. We can divide everything by 2, by the way. Divide everything by 2, that's going to be 4. This is 2 plus root 3. Then here we can multiply with the conjugate, which is this, to rationalize the denominator. So this will just be 8, 4 root 3. Down, you're simply going to get a 4 minus 3. This is just a 1. So the answer is at 8, 4 root 3. So this is what you get. Now probably I'm a little bit too fast, because I'm doing this so that I am able to beat time in terms of my laptop not going off. But let me just scroll back a little bit. So the main idea here is, first of all, to convert the angle given here in from radians to degrees, because it's very much better to work with degrees than radians. Few people are conversant with working with radians. So we did the conversion, we got a 15 degrees. So hope that's okay. That's what everyone is getting. We're just multiplying pi over 12 multiplied by 180 over pi, right? The pi cancelled. 6 there is simply 2. Then 6 in 18 is simply a 3 with the 0, right? Then 2 there is 1. 2 there is 15. That's where the 15 came from, right? So we're saying that's why we have this. Then we know what sec is. Sec is the same as 1 over cos. So if the sec is squared, even the cos also has to be what? Has to be squared. That's what we're saying. It won't make any difference with what we've done here, what I wrote here, because 1 squared is still 1. This squared is still cos squared of 15. Then we first of all have to get cos 15, which is just using the double angle for cos A minus B, which is just the same as cos A, then cos B, then we say plus sine A, then sine B. So according to the double angle for cos, it does the opposite. If there's a minus here, meaning here there's going to be a plus. So that's the rule that we applied. We're getting these ratios based on those special two triangles that you should master. There is this one here with a 30, a 60, a root 3, a 2, and a 1. That's why we're getting this when we say cos 30, sine 30. There's another triangle for the special angles. So there's 45 and there's a 45. There's a 1 and a 1. So these are already like this. You just have to get your cos 45 and your sine 45. So that's how we got this to be our answer for cos 15. Now this is cos 15. We're looking for 1 over cos 15. So 1 over cos 15 will be the reciprocal of this, which is 2 root 2 over root 3 plus 1. When we are done, we need to square this. So when we're done, we needed to square this. That's what we did. When you square it, that's how we landed on this part. Simplifying it, it simply gave us this expression, dividing everything by 2. Then we got this. Now we have to conjugate, or rather rationalize. This is how we got this, because we don't want to see the radical in the denominator. That's the main idea there. So that answers your question 2. Then the next one, which is question, this is now B. So B is something we've done before from your tutorial sheet. They're simply saying we have cos A. So there's cos A, which is the same as negative 3 over 5. And it's found within 180 to 360. So which quadrants can we find between 180 to 360? So if you write your x or y thing, this is 0, this is 90, look at the 180, look at your 270, look at the 360. Between 180 to 360, we have the third quadrant and we have the fourth. Between these two, the only place where we can find cos being negative is the third quadrant, right? So we're going to make up a triangle. The nice logical way to do it is to write something that looks like this. Make your triangle look like this. You have your 90 degrees there. So this is your A here. We're saying cos A is adjacent hypotenuse. This is what you're having. So how do we get this other part here? This is going to be 5 squared is equal to negative 3 squared plus the y value. This is going to be 25 minus a 9. This is y squared. This is 16 is equal to y squared. You can square root both sides. Y is equal to negative 4 because we're going down, right, in the y direction. This is important to note. So you have this first triangle. So we know we're dealing with a third quadrant, meaning only tang has to be positive. The other two guys are going to be negative because we're dealing with a third quadrant. Then there's also sin B. Sin B is equal to root 3 over 2 between 90 to 270. The only place where sin is positive is the second quadrant. So this will help us create a triangle in the second quadrant. This is opposite, this is this, then this is that. This will be a negative 1. This is your B there, right? This is what you have because this is the third quadrant. This is in the second quadrant. Then the first question there that they're asking is sin A. So they want us to get sine of, this is cos, sorry, they're asking for cos. So number 2b 1, they're asking for sine. This is a plus b. Sorry, it's cos. Don't want to keep on making this. So it's cos. This is what you have. This is going to be cos A, then cos B minus. This is sine A. Then you have sine B this side. So we just go back to our triangles now. We get what we are given here. So cos A is equal to what? Adjacent over hypotenuse, right? Negative 3 over 5. This is a 5 there. Cos B is what? Adjacent, which is negative 3 over hypotenuse. So it's negative what? Negative 1 over 2 minus sine A is this over 5. Sine B is simply root 3 over 2. So we're having this. So we need to take the correct quadrants because the signs on the ratios will matter. Like how cos B is negative because we're dealing with what? With the second quadrant. This is now going to be 3, 10 minus. This is going to be negative and negative. That will end up being positive. 4 root 3 over 10. Common denominator here is 10. We're having 3 plus 4 root 3. So this is your answer for cos A plus B. This is what you get. Then the next one, they're simply asking us to get sine 2A. Then we have plus 2B. So this is the same as sine 2A. Then we have cos 2B. Then plus, this is going to be sine 2B. Then we have cos 2A. So now we know what sine 2A is. So not sine 2A. Sine 2A is just going to be the same as 2 sine A and what? Sine B, right? That's what you have. Then also you have the same thing as sine 2B will be the same. It's just 2 sine B. This is going to be cos, This is cos, sorry. This is cos A. This is also cos B, right? So now we have this. We know what 2 is. We know what sine A and what cos A are going to be. Same applies here. We know what sine B and what cos B are going to be. So sine A Sine A, we already got this. I mean, cos A, we already have this. Wherever there's cos A, we can put this guy. Cos A. So if we go back to our triangles, so according to the information we have from the two triangles, we have cos B. So cos B can be gotten from here. So we said cos B is what? Adjacent over hypotenuse. So this is what we are getting here in our expansion. Writing this, it's simply going to be 24. This is a 24. This is 2 times 8, 8 times 3, right? Yes, it's 24. Down you're simply getting a what? A 25. Then this here is negative. The 2 and 1, 2 can cancel, meaning we're just having negative root 3 over 2. Hope that's okay. Then from here, we only got for sine A and sine B, right? We need to get for cos B as well. Cos 2B, I mean. So cos 2B is simply going to be cos squared of B minus sine squared of what? Of B, right? Then you also know what cos 2A is supposed to be. It's simply cos squared of A minus then sine squared of A. So this is just going to be, so this will just turn out to be this the following expression here. So we're having cos 2B is equal to, this is just a 1 over 4 minus a 3 over 4. This will just be negative 2 over 4, which is just negative half. Then cos 2A is simply the same as, this will be a 9 over 25 minus a 16 over 25. This is just going to be a 9 minus this, that's going to be negative 7 over 25. So we now have everything that we need. We have this, we have that, and we have this guy, and we have this. So we can now replace them back here in this expression. Yeah, so we can now go straight ahead and replace. So we are saying the sine 2A plus 2B that we have, which is the same as sine 2A. Sine 2A, now we got 24 over 25. So this is 24 over 25. Then cos 2B is negative 1 over 2. Then plus sine 2B, so sine 2B is negative root 3 over 2. Then cos 2A is just negative 7 over 25. So this is now going to be negative 24 over 50 plus, this is going to be 7 root 3. Down we're having a 50. So this turns out to be 50. We have a 7. This can just be written at negative 24 plus 7 root 3, which is the same as 7 root 3 minus 24 over a 50. So this is what they wanted for question 2B part 2. That was what was required. Yeah, that's what you have. Then the next question that we're having, so that's the answer here, that's your 5 marks. The next question is an equation. They want us to solve this expression giving all the possible answers between 0 to 180. Those are the only answers that they want. Yeah, so we're going to have the equation. This is question 2C, by the way. So our 2C is 2 cos, we're having a double angle, cos 2x. Then we have tan 2x, they're all double angles. This is equal to 1, then plus your tan 2x. Then this is minus 2, then cos 2x. We can have it as 2 cos 2x multiplying sin 2x. Then this is cos 2x is equal to 1 plus sin 2x over cos 2x minus 2 cos 2x. Already here we can cancel this. We can cancel this expression. This is just going to be 2 sin 2x. Then here we're having the common denominator here is going to be, we say cos 2x. This is just cos 2x. Then we're having plus sin 2x. This is just going to be 2 cos 2x and another cos 2x. We can multiply, cross multiply. This will be 2 sine 2x and cos 2x is equal to cos. Now we're having cos 2x plus sine 2x, then minus 2. Then we are having cos 2x this side. This is cos 2x and cos 2x. This is what we're having. So from here, we can try to gather anything that may give us something like terms. So we can have 2 sine 2x and cos x minus sine 2x. Then we have plus 2 cos x, cos 2x and cos 2x minus cos 2x. So here, if we try to factorize what's common here, this is sine 2x. This will be 2 cos 2x minus 1. What's common here is cos 2x. This will be 2 cos 2x, then minus 1 is equal to 0. This will be sine 2x plus cos 2x. And we're having 2 cos 2x minus 1 is equal to 0. Then here, we can solve each one of them, equate them to 0. 2 cos 2x minus 1 is equal to 0. 2 cos 2x is equal to 1. So this will just be, we do this, so cos 2x is equal to 1 over 2. So 2x is equal to cos inverse of half. What angle gives us half for cos? So if you go back on your special angles, you have what? You have cos is adjacent, right? There is only a part that we can possibly get a half is this one. We have a 30, we have a root 3, we have 1, this is 60 there. So 2x is supposed to be equal to 60. The other angle where cos is also positive is what? The fourth quadrant. So 360 minus 360, we get what? A 300. So we can divide this guy by 2, this guy by 2. So x can either be a 30 degrees or a 150 degrees. We keep these two. So we've gotten the first two values of x. Then we come here again. We had this piece. This is sine 2x plus cos 2x supposed to give us 0. I'll divide everything by cos 2x here, by cos 2x, by cos 2x, so that I can get my tan. This is just tan 2x plus 1 is equal to 0, meaning tan 2x is simply negative 1. So 2x is equal to tan inverse of negative 1. This is just going to be a negative 45. Where else is tan negative apart from the fourth quadrant? It's in the second quadrant, right? So this is coming from the fourth quadrant, or rather I'll just say this is the same as 315, right? When you say 360 minus 45, that's a 5, that's a 1. The other place is the second quadrant. The second quadrant will just be 135 when you say 180 minus the 45. So now we can divide both of these guys by 2. So we are going to have 315 over 2 and 135 over 2. Yeah, so we have 4 sets of answers. These are the values of x. Yeah, so if this is a little bit confusing, there's a separate video on trigonometric equations that you can watch. This is similar to identities. The only difference is that we have to finish them off by getting the actual values of x, and they have to be in the interval given. And because the interval was in radians, even these angles also, the answers have to be in radians. So this is just going to be a pi over 6. Then this you convert it. This is one what? We say 1. This is there's 180 down here. This cancels. 5 there is 3. 3 there is 5. Then 3 there is what? 3 there is 6. So it is the same as 5 over 6 pi. Same applies here. You can convert them to radians as well. So that answers your question number 2C. Now we can go to this other question here. The question number 3A is an identity. Now there's a separate video for this. It's just a 6 minutes video. It's written identity example. It should be just underneath this same particular video, so you can check it on the playlist. So it's already done. We already did this. I made this already, so you can check it out. Then the last part is asking us to sketch. So they're saying for the function below, state the period, amplitude, phase shift, and the vertical shift, and then sketch its graph in the interval -20 to 100 degrees. So this is the equation, the question that we have. So if we may solve it on a separate part, so this is 3b. You have y is equal to -1 plus 2. This is sine 6x, then this is plus 120. So if you want, you can pause the video, attempt it first using the rules that we learned, then see if you are going to get the same answer like that that we were going to get. So here we're going to have the period. The period is simply going to be a 360 divided by what? B, right? Our B here is 6. What's in front of your x? Yeah, so we're having 2 pi, or rather we can just say 360. Then the phase shift, so you write them. This is a mark to just show them like this. Phase shift, we'll say 6x plus 120 is that 6x is equal to -120. Divide this by 6, meaning x is -20 degrees. So this is a shift to the left, so it's a left shift. That's what you have. Then the amplitude is just the modulus of 2, which is just 2. The vertical shift is just -1, so we say downwards. So we're moving this thing downwards by a single step. So we'll first of all sketch the general graph. The general graph for sine is simply going to be given as follows. So the period just tells us that we have 6 waves, and each wave is going to be seen every after is it 60 degrees or something. So we're having a wave here, there's a wave there, that's 1, this is 60. This here is going to be 120. Another 60, that's going to be 180. Another 60, that's going to be a 240. That's going to be a 300. That's going to be a 360. So these are the 6 waves, right? 1, 2, 3, 4, 5, 6. That's what you have. Then you have 1 and the -1. So this is a 0. That's according to the first part. Then we move this thing backwards by 20. So this is already at what? This is 30, meaning this is what? This is 90. Then this is, okay, yeah, so this is supposed to be what? Plus 30 here, that's going to be 150, and so on and so forth, right? So if we move it backwards, because they're saying we need to move it backwards by, the first shift is what? -20, right? So 0 comes at -20, 30 comes at 10, 60 comes back at 40. Yeah, so, okay, so the 30, I don't really have to show this. I needed to just show this part. So we're having something that looks like this, comes there. So 120 comes at 100, right? 90 comes at what? 70, right? So they just wanted the part from -20 to 100. Forget everything else. So meaning we're going to omit everything else. It's irrelevant. So this is basically what they wanted. So this here is a 70. This is just for your sake, for you to understand where we're coming from. So this is not relevant. We don't need any of this. They just want this same piece from -20 to 100. Then from here, we can now apply the amplitude. So this thing is going to be magnified by a factor of 2. So meaning it goes at 2 and also at -2. So I can now erase this one. Then from here, we're saying we need to move this thing a step down, right? So we have to move this thing by a step down. So meaning our new line of axis will be -1 now. This is where we are at. If we are moving it, so let me use a different color. If we are moving it down, so the points that we are on at 2 are simply going to come at 1. The points that were at 0 will come at -1. The points that were at at -2 will simply come at -3. Yeah, so we're simply going to get something that looks like this. Something that looks like this comes there, passes there, and comes there, passes there, then comes there. This is what we are having. Yeah, so I can erase these other guys. No need of erasing this, but you can still just erase it for you to see what's happening. So if we erase it, it's simply going to look like this. It has moved down, but let's just show that we're actually here initially. This was the line of thing. So the domain has been restricted to be between -20 to 100 degrees. The range, on the other hand, is just from what? This is now a 1. The range is now between -3 to 1, because the smaller one is -3, the highest is 1. So this is what you have. The rest of the information was given here, vertical shift, everything here. Then you score your full marks. So this is 7 marks in total. So this brings us to the end of quiz 3 from the 2024 academic year. Yeah, so if you do have any questions, please feel free to reach out on WhatsApp. The number should be there on the YouTube page. Thank you so much.